The Wavemaster 8000 HD high-definition oscilloscope with an external high-performance MSO, the HDA125, easily performs decode and triggering for the DDR5 standard. This enables validation stages to more accurately identify read and write packet types. We have a DDR5 DIMM running at 4800 megatransfers per second while connected to a PC. We're running memtest software, which outputs a random data pattern to the memory, perfect for signal characterization. Connected to this device is a DRAM interposer, which provides high-quality connections for probing. As you can see on the scope screen, there is a DDR5 clock, data, and strobe in digital channels that also represent the capture of the chip select and command address signals. Engineers' workflow require turn-on and validation testing, so it's important to have toolkits like this one that include decoding for DDR5. Simply open the toolkit, select DDR5 protocol from the list of standards, then choose the corresponding speed you're testing. You can choose up to 8400 megatransfers per second. Now, poor signal quality can make bidirectional data for read and write packets extremely challenging to separate. So by upgrading our setup to the HDA125, we can now switch from a phase analysis to a command bus to do our signal separation with higher accuracy. Pressing the setup button will take you to a redesigned command bus and decode tab. This workflow is left to right, and all the setup can be done right here. First, you'll want to make sure the HDA125 is turned on and showing connected. Then you'll select a digital segment you prefer to use. I'm using Digital 1. The second part is the channel selection. It synchronizes with the digital setup menu and relabels all the on-screen channels we've matched together to the corresponding digital menu and bus decode setup menus automatically. Next, set up the DRAM read and write packet latencies. I'll set mine to 1439, but notice the overlays shift over the packet. This visually lets you know if it's a read or a write and which ones are being detected. It also tells the software which packets will be used for eye diagram and measurement analysis. Set up your thresholds, then move to the decode section. Pick which decode you'll use, then decide which channels get visual overlays of the packet channels. Finally, on the right is DDR triggering. Pick from a wide assortment of packets that the HDA125 analyzes. This could be read, write, bank activate, or a variety of other trigger types. Once complete, the command bus table lists all of the decode packets, their time in the acquisition, the number of clock cycles, and more details. For DDR5, there are over 20 different packet types that can be identified from the JEDEC command truth table, found in the specification. Click on any row in the table, and it'll take you right to the packet location. This toolkit enables decode and triggering capabilities and is essential for early validation of packets, and is worth using as you prepare and perform compliance testing. Reach out to us if you have any questions or would like to get a demonstration from your local sales representative.